Hello students. So until now, you all may have got 9 lectures from this units and dimensions. This is the 10th lecture of units and dimensions. So this is from the subject physics, class 11th. So now in this chapter we are going to start about the propagation of errors. So let's go to the contents section. Let's first of all go to the contents of this chapter, in which we have already studied introduction, unit systems, dimensions, applications of dimensional analysis, limitations of dimensional analysis, significant figures and rounding off, calculation of significant figures, errors in measurement. Now in errors in measurement, in the previous lecture we have already studied 2 topics. So let us figure out what those 2 topics are. So the first topic was types of errors. The second topic, which we had already studied, is representation of errors. Okay, so now we are going for the topic which we are going to study in this lecture will be propagation of errors. So first of all, let's understand what this propagation of errors mean. So, for example, let's suppose we are adding 2 physical quantities, or we are subtracting 2 physical quantities, or let us suppose we are dividing 2 physical quantities, or we are multiplying 2 physical quantities. Now, in this case, if we have got an error in one quantity and similarly we have got error in another quantity as well, now that error will pass on to the answer. Okay, so when we will get an answer, we will get some error in that answer as well. So, the topic that we are going to study right now is related to that part. So how the error propagates from a particular quantity to the final answer. So that we are going to study in this lecture. So let's go straight away to the lecture. In this slide, we are going to study about the propagation of errors in case of addition. So let us suppose we have 2 quantities x and y, which when added give another quantity, that is z. So consider z is equal to x plus y. If delta z is absolute error in z, delta x is absolute error in x, and similarly delta y is absolute error in y. Now, what this absolute error means and what fractional error is or percentage error is, we have already discussed in the previous lecture. If you have got some confusion in there, you can just revise the previous lecture and you can get it clearly. Now, in this case, you can see that I have absolute error in z is delta z, and absolute error in x is delta x, and that in y is delta y. So, we can say this implies this z plus minus delta z is equal to x plus minus delta x and plus y plus minus delta y. So the first point I would like you to keep focus on is this plus and minus. So why do I keep plus and minus over there? It's because that this error can be positive as well as negative. What we have studied in the types of errors part. So we have studied over there that this error in x or in y, it can be positive as well as negative. So that's why we keep here plus and minus. If the error is positive, we will use the plus sign, and if the error is negative, then we will use the negative sign. Okay, so can I write it as, this implies we can say z plus minus delta z is equal to x plus minus delta x plus y and plus minus delta y. Is that correct? So if you see there is x and this y, so let us rearrange the terms. So we can write it as x plus y and then plus minus delta x plus delta y. Is it correct? So now you can see, now we already know from this equation number 1 that x plus y is equal to z. So would that mean that this term we can replace with what? Z. So we can say z plus minus delta z is equal to, now in this place of x, y, we can write it as z plus minus delta x plus delta y. So if you see this z, if we take it here, if we can write it as z minus z plus minus delta z is equal to plus minus delta x plus delta y. So this cancels out with this, so we can say that plus minus delta z is equal to plus minus delta x plus minus delta x plus delta y. So would that mean the total error in z is given as what? So delta z, the total error in z, after adding these two terms, the error in x and error in y is getting added up. So we can say this is delta x plus delta y. So this is the total error which will be propagated to the answer. So how can we write it now? So if this is the absolute error, now remember this is absolute error in z. So what will be then the fractional error? So this implies the fractional error in z can be written as delta z divided by z. Similarly, the percentage error will be written as delta z divided by z multiplied by 100 and the sign of this percent over here. So did you understand that? So let me repeat this again for you. You can see that here we have got a quantity which is z, and that z is equal to x plus y. Now we have got absolute error in z as delta z. Similarly, absolute error in x is delta x, and absolute error in y is delta y. So this means that the z term is not actually z, just z, it is z plus minus delta z. For example, this is the value of z and some error which will be generated while measuring this value z. So we can say z plus minus delta z is x plus minus delta x and y plus minus delta y. Now from here to here it's calculation, and we can see here we see a term of x plus y coming out, and this x plus y using equation 1 is equal to z, so we can write it as equal to z. So when we take this z from this RHS to the LHS, so z minus z will be equal to 0, so that means delta z will be equal to plus minus delta x plus delta y. So that means the total error in z will be delta z is equal to delta x plus delta y. And similarly, we can write fractional error as delta z by z and percentage error as delta z by z multiplied by 100. Now you can pause the video here and you can write it down. Okay, so let's go to the next slide. Now in this slide we can see that we are studying the propagation of errors, but now that the propagation of errors is being studied for the case of subtraction. So let us suppose we have got a variable, or we have got a value after subtracting two terms, that is z is equal to x minus y. Consider delta z to be absolute error in z. Similarly, delta x to be absolute error in x, and delta y to be absolute error in y. So then can I write it as z plus minus delta z is equal to x plus minus delta x, and then minus and y plus minus delta y. You can see earlier this x and y was being added and we had a positive sign over here, and now in this case this x and y are being subtracted and we have got a negative sign over here. Okay, so this means, okay, sorry for this, so this actually is z here, Okay, so this means we can write it as, z plus minus delta z is equal to x plus minus delta x minus y, and now when this minus gets multiplied to plus, it becomes minus, and when this minus gets multiplied to minus, it becomes plus. So plus will convert into minus, and this minus will convert into plus. Got it? So this means we can write it as z plus minus delta z is equal to x minus y plus minus delta x and minus plus delta y. So now this x minus y using equation 1 is equal to z. So we can write it as, using equation 1, we can write it as what? We can write it as z plus minus delta z is equal to z plus minus. Now see, if we take out plus out here, so there is minus, and if we take minus over here, and there is plus. So I will take plus and minus both out, so I will write it as delta x plus delta y. Good? So now if we take this z from here and take it to this side, to LHS, then we can write it as z plus minus delta z minus z is equal to plus minus delta x plus delta y. Now this z minus z is 0, so we can write it as plus minus delta z is equal to plus minus delta x plus delta y. So this means the absolute error in delta z is equal to delta x plus delta y. Now this is the point you should note it down, because this is a very important point. Now see, the slide, the propagation of errors in case of addition, you see the total error which propagated to the result, that is delta x plus delta y, and the same is in case of subtraction also, delta x plus delta y. So in case of subtraction, it doesn't happen that the errors of these two quantities, they get subtracted. No, but the errors of these two quantities get added up again, because you don't know if the error is negative or the error is positive. So they get added up. So in this case, the total error won't be delta x minus delta y, but it will be delta x plus delta y. You got it? So you have to remember this. Okay, so remember this part, because in case of subtraction also we have got positive sign, and in case of addition we have also got positive sign. So this means, so this is absolute error in z, no? Absolute error in z. So what will be the fractional error for z now? So the fractional error in z, so that will be delta z divided by z. So that means delta x plus delta y divided by x minus y. So this will be the fractional error in case of z. So what will be the percentage error? So in case of the percentage error, we will just multiply 100 to this delta z by z. So we can write it as delta z by z multiplied by 100, and percent will be equal to delta x plus delta y divided by x plus y and multiplied by 100 and the percent sign over here. Did you get it? So this is, oh sorry, that's actually minus sign over here, no? So this is actually the negative sign. So x minus y. So this is the propagation of error in case of subtraction. Now the very important point you have to keep note of and you have to remember is this. In case of subtraction also, the error adds up and does not get subtracted. This is a very important point, and this is a very common mistake people do while calculating the total error in case of subtraction. So in case of subtraction, the error doesn't get subtracted, but it gets added up. So note down this point on your notebook, okay? So let's go to the next slide. First of all, you just pause the video and write it down. Okay, so let's go to the next slide. Now, in this slide, we will be studying propagation of errors in case of multiplication. So, just put down your copy and pen and just look at the board and understand what is happening over here, because you need to understand the actual process. So, let us suppose we have got a function z is equal to x divided by y. Similarly, let us suppose delta z is absolute error in x, delta x is absolute error in, sorry, this is absolute error in what? This is absolute error in z, and this here is absolute error in x, and this delta y is absolute error in y. Okay, so does that mean we can write it as z plus minus delta z is equal to, oh sorry, this is multiplication, so let me change the function. This is x multiplied by y. Okay, so now I can write this as z plus minus delta z is equal to x plus minus delta x multiplied by y plus minus delta y. So let's just solve this equation. So the result you will get will be something like this. So that is x y plus minus x delta y, and then plus minus y delta x, and plus minus, and then plus minus delta x delta y. Now, let me give you an idea what the error is and what the value of quantity is. For example, if you get the value of g to be 9.81 meter per second square, okay, this is the standard value of g on the surface of earth, okay. So for example, when you will be calculating this value of acceleration due to gravity using a simple pendulum, for example, you get a value of, let us suppose, 9.92 or 10.01. So this is acceptable value. Why is it acceptable value? So because this value doesn't vary a lot from the actual value. So the actual value is 9.81. Now if you get a value of 9.92, even then the value does not shift so much that we can say that our experiment is wrong. Okay. Now if somebody, for example, the value of g is 9.81 meter per second square, fine. So what if somebody gets a value of, let us suppose 17.21 or 20.74 meter per second square? Will that be acceptable? No, it won't be. Why? Because in this case, the value of error is almost double that of the actual value. Okay? So that means in this case, the value of acceleration due to gravity won't be acceptable, and this will be considered to be wrong even after taking error into consideration. Now in this case, as the value does not deviate from the main quantity that much, we can say that there is a slight error in the measurement, and we can consider that that's fine, that's good, so this is a good result. Did you get it? Okay, so now, so that means, okay, for example, let me give you another example for to understand this concept over here, because I'm going to leave this delta x delta y over here. Okay, so now you need to understand why did I do that. Let us suppose the value of g is 9.81 meter per second square. Okay, so this is actual value. Now let us suppose calculated g comes out to be 9.89 meter per second square. So what's the error over here? So the error is delta g is 9.89 minus, actually it is true value minus calculated value, so we can write it as, so true value is 9.81 minus 9.89, so that means the delta g value is 0.08 meter per second square. Okay, so now if you analyze this, the value of delta G is very small as compared to this actual value of this G. So that means, for example, if you have 0.01 multiplied by 0.02, this 0.02 is a small quantity, fine, and 0.01 is a very small quantity. What happens when we multiply them? See, so the result will be 0.0002. So is this number greater than this? No, it's lesser than this, and it's lesser than this one as well. So that means if you multiply two quantities which are way below than 1, then the result we get is much less than that. So it's much less. So that means if we multiply two very small quantities, then their multiplication will be very small and we can neglect it. So that means this delta x and delta y can be neglected. So we can write it as, now as delta x and delta y are very small, then delta x and delta y will be much smaller and hence can be neglected. Okay, so then what do we write this equation as, if we have to neglect that? Okay, delta x delta y, so then what do we write it as? Let's see. Okay, so let's see how we can write this equation now. So we can write this equation as z plus minus delta z is equal to xy plus minus x delta y plus minus y delta x. Okay, now see this, x plus minus delta z, okay, z plus minus delta z. So this xy, can you see this? So using equation 1, we can write this xy as z, no? So z plus minus x delta y and plus minus y delta x. So that means if you take this z from RHS to LHS, we can write it as z minus z plus minus delta z is equal to plus minus, we will take common, and we can write it as x delta y plus y delta x. So that means this z minus z is 0, so that means plus minus delta z. So that means plus minus delta z will be equal to plus minus x delta y plus y delta x. So that means the total absolute error in z that propagated from this question to the answer, that will be given equal to x delta y plus y delta x. Okay, so this is the absolute error in z. So what will be the fractional error in z? Let's see. So in case of this z, the fractional error is delta z by z. Okay, so that will be written as x delta y plus y delta x divided by x into y. Okay, so divide this for this term as this term also. Okay, so let's break it into two parts, and then if we take LCM, we can get the same thing again. So we can write it as delta z by z is equal to x delta y divided by xy plus y delta x divided by xy. So here this x cancels out and here this y cancels out. So that means fractional error delta z by z will be equal to delta y by y plus delta x by x. So this is the fractional error in z. Okay, so you have to remember this formula because this formula is going to be particularly important when we are going to solve the questions regarding this chapter. Okay, so now what will be the percentage error? So the percentage error will be simply delta z by z multiplied by 100 100%. So the value for the fractional error you get over here, just multiply 100 and put the sign of percentage over here and you get the percentage error. So is that fine? So I hope you have understood this. If you didn't understand this, just pause the video, follow the steps, and then we'll go to the next slide. And also write it down. Okay, so let's go to the next slide. This is the propagation of error in case of division. So this is the fourth one now. Okay, so let us suppose we have got a quantity z is equal to x divided by y. So if delta z is absolute error in z, similarly delta x is absolute error in x, delta y is absolute error in y, then we can write this equation as, let us suppose this is first, so we can write it as z plus minus delta z is x plus minus delta x divided by y plus minus delta y. Is it fine? So let's do one thing. Let's take x common from here and y common from here. So we can write it as z plus minus delta z. So this is actually delta z over here. So delta z is equal. So let us take x from the numerator common and y from the denominator. So can we write it as x goes like this? So that's 1 plus minus delta x by x. See, if we multiply the x again, so 1 multiplied by x is, okay, so 1 multiplied by x is x again, and if we multiply x here, this x and this x gets cancelled out, so that's delta x, so same as that in the numerator. So divided by, let's take y common from here, so that is 1, y we take common, so 1 plus minus delta y by y, okay. So can we write this as z plus minus delta z is equal to this x plus y will go like this, and then this numerator, okay, 1 plus minus delta x by x. So can I write the other term as 1 plus minus delta y by y raised to power minus 1. Let me remind you again what I did here. We know if we have got 1 divided by x raised to power n, we can write it as x raised to power minus n. I have told you multiple times about this. So this is what I did here over here. Now we are going to use binomial theorem, and I will remind you what we studied in binomial theorem after the approximation part. So we studied if we have 1 plus x raised power n, that comes out to be 1 plus nx, provided x is very smaller than 1. Good. So you can see delta y is very smaller quantity, y is a bigger quantity. When we divide bigger quantity, for example, let us suppose this is 0.1, we divide it by 10, so that will be 0.01. So it will be much lesser than 1. So in that case, this we can use that binomial theorem over here directly. Okay. So let us use this binomial theorem and see what is going to happen. So that is z plus minus delta z is equal to this x plus y. Using equation 1 is actually z. So that is z. This will be 1 plus minus delta x by x, and now here this 1 minus 1 will be multiplied, so we can write it as 1 minus plus delta y by y. Is that fine? So now if we take z common from here, we can write it as z 1 plus minus delta z by z is equal to z into 1, okay, then minus plus delta y by y, then plus minus delta x by x, then again plus minus delta x by x and delta y by y. Okay, now again you can see this delta x is very small quantity, delta y is very small quantity. When we divide it by x multiplied by y, then it becomes a much smaller quantity. So if this delta x multiplied by delta x is already a smaller quantity, if we divide it with a much bigger quantity, won't it become much more smaller? So then we can neglect this part over here. Okay, so this z gets cancelled out with this z, and also this delta x delta y is very small, so this is very small, thus delta x by x multiplied by delta y by y can be neglected. Okay, so that means we can write it as 1 plus minus delta z by z, and from this side we can write it as 1 minus plus delta y by y, and then plus minus delta x by x. The other quantity we have neglected. Okay, so if you see here, now if you see here, we can see that the 1 here and 1 here, if we take 1 here, it will be subtracted, so that will be 0. So this implies we can write plus minus delta z by z. Okay, now you see this term, there is minus, there is plus, there is minus, there is plus, so we can write it as plus minus will go out, and that will be delta x by x and plus delta y divided by y. So that means fractional error delta z by z is equal to delta x by x, okay, plus y delta y divided by y. So this is the fractional error we will obtain in case of z. I think yes, that's fine. So this is fractional error. So what will be the value of percentage error? So if we see percentage error, we can write it as delta z by z multiplied by 100% will be equal to this delta x by x plus delta y by y multiplied by 100 and the percent sign over here. So this will be the propagation of error in case of division. Now you can see in case of addition as well, multiplication as well. See, in case of multiplication as well, you have got the same value of fractional error, and in case of division as well, you have the value of fractional error is same. In case of multiplication, we also write it as delta x by x plus delta y by y is equal to delta z by z, and in case of the division as well, we write it as delta z by z is equal to delta x by x plus delta y by y. Do you get it? So just keep this in mind. Otherwise, you are going to make mistakes while solving questions. Okay, so this you have to keep in mind. It doesn't change for multiplication or division and the same is true for the addition and subtraction. In the addition, it's also delta x plus delta y. In case of subtraction, it's also delta x plus delta y. Is it good? So just pause the video and write it down. Follow the steps, write it down, and then we will go to the next slide. Okay, so this is the another type of propagation of errors where we will be talking about power of a quantity. Okay, so let us consider z. Let us consider z is equal to x raised to power n. For example, delta z is absolute error in z, and delta x is absolute error in x. Then can we write it as z plus minus delta z is equal to x plus minus delta x raised to power n. Now do one thing, this over here is z. So now do one thing, take z common from one side and x common from another. So can I write it like this? So we can write it as z1 plus minus delta z by z. Okay, if you multiply this z again, you can write it as z plus minus delta z, same which you have got earlier. So in here you can write it as x and then 1 plus minus delta x divided by x whole raised to power n. Now this n is power for both 1 plus minus delta x by x, this term, and also this x term. So we can write it as z 1 plus minus delta z by z, okay, and here x raised to power n and 1 plus minus delta x by x raised to power n. Now this z is also x raised to power n. See equation number 1. So using equation 1, we can write it as z 1 plus minus delta z divided by z is equal to z, and this will be 1 plus minus delta x divided by x raised to power n. So this z will get cancelled out with this. So the final result will be 1 plus minus delta z by z is equal to 1 plus minus delta x by x whole raised to power n. Now this delta x is a very smaller quantity. When it gets divided with a bigger quantity, now this term will take a value which is lesser than 1. So in that case we can use the binomial approximation. I will remind you again. So I told you over there 1 plus x raised power n, if x is much less than 1, it will be equal to 1 plus nx. Similarly, if we have 1 plus x raised power minus n, we can write it as 1 minus nx. So can I write it as 1 plus minus delta z by z is equal to 1 plus minus n times delta x divided by x. So this 1 over here, 1 minus 1 plus minus delta z by z is equal to plus minus n times delta x by x. So 1 minus 1 is 0. So that means plus minus delta z by z is equal to plus minus n times delta x by x. So that means fractional error in z. So what will that be? That will be equal to delta z by z is equal to n times delta x by x. Now analyze this result and see how you need to remember it. Okay, see. If you see, there is z is equal to x raised power n. In case of error, this n comes down and we write it as delta z by z is equal to n gets multiplied now delta x by x. So this is fractional error in z. So if we have to write the percentage error, how are we going to write that? So percentage error is delta z by z multiplied by 100% will be equal to n delta x by x multiplied by 100 and the percent sign over here. Did you get it? So this is how the error propagates in a question where we have a power of some quantity, and you can see that like this is a very important result. You have to remember this. So from this we can get the percentage error also, and now you can see how the error propagates in this case. Now at this point we are going to stop the lecture, and with this we completed our propagation of errors part. In the next lecture we'll be focusing on the question solving of errors, calculation of errors, fractional and percentage errors, and other questions which have already appeared in Neet and JEE examinations. Until then, take care of yourselves. Goodbye. Allah Hafiz.